thank you everyone for joining us. Happy to have you here. Today, our webinar is called Introducing HeadSpin Regression Intelligence. Please remember to put any questions into the Q&A tab, should be near the bottom of your screen, and we will answer them near the end of the event. Our presenters today are Brian Caldwell, co-founder and CTO of HeadSpin, and Ilya Drakester, VP of Worldwide Customer Engineering. Now to introduce our exciting product, here's Brian.
Hi guys, I'm going to share my screen. Great, thanks for joining today on this exciting topic where we kind of talk about where we're going with our product, how we see the industry coming together in terms of making testers more efficient, and then to give a demo and deep dive into what we call regression intelligence. So for us, regression intelligence are AI workers that run and identify areas of risk. And we think this is really important because we see an overall direction for testing to focus on efficiency. So rather than just running your tests and getting your pass fails, we think there's so much more signal that can be given from a platform and from tools to help testers do more. So in the pre-release, when testers are running functional tests, we can also be measuring performance data and adding additional test criteria around performance data. We can make small changes to test logic, which we call visual analytics, to help target additional areas of risk, such as how long it took the application to respond to user interactions, how long it took for screens to load. And so these add more signals that can be used to glean additional insights into how the application is performing. Also, those same functional tests that you're running pre-release and you're using to test performance can be run post-release, and you can actually measure the performance of live product. And so at HeadSpin, we believe that there's a collaboration between all of these parts of testing so that the same practice that you're currently doing, you can use to get more data and more insights into your application. We also think that there's collaborations between testers, product development, site reliability, and performance teams that additional tooling can really help. And our goal with regression intelligence is that we have these workers that are running automatically in the background, helping you to identify areas of risk in the data in an actionable format that helps you collaborate across teams. So for example, if you're running functional tests pre-release and you're measuring performance data, our view is that these workers, once configured, will be able to sift through all of the performance data that you've generated and help you understand what's useful in the data and what can you use to collaborate with the product development team, with the reliability teams, and the performance teams. How can you further have a conversation to make the product even better? And so what that looks like in terms of collaboration is HeadSpin is a data-rich platform. We surface a lot of data on every test. This is an example of what that looks like. So not only do we run your functional test, but then while your functional test is running, we're collecting data about the device, the network, the video, and we're analyzing it. We're also allowing your test to add small metadata to the test called visual analytics, where you can tag different points of the test for further analysis, such as how long it took to load, how long it took to respond. And so when you run a test suite, typically you end up with hundreds or thousands of these traces. And the question is, how do you make sense of them? How do you go through and understand what got worse? What are truly the areas that you could have the biggest gain when you apply further fixes with the team? And where could you actually focus on more testing? So for example, if you notice that certain user journeys have particularly high amounts of performance issues or user experience issues, how do you refocus your testing to go deeper to really understand what's causing those issues? And at HeadSpin, we believe in what we call a continuous data model. The testers and the developers and everyone is in the same data stream. It's a stream of test sessions that are organized by user flows. So every time you run a test session, whether it's through automation or a manual test, it gets put into the system. and organized into a user flow. There are labels and visual analytics applied within the test sessions. And what we have is basically a giant stream of data that's being continually collected and exported to a database and dashboards. Within this data model, we've introduced this new concept called a regression intelligence worker that runs once or runs continuously in the stream, and is defined by parameters such as the current build versus the previous build, the current day versus the previous day, one region versus another region, and is continually running and outputting analysis results. So what we see is there are many different types of breakdowns of the data that are useful. And within our data model, what we allow is the tagging of the data. So as customers become more embedded with our platform in their daily practice, more and more tags show up. And this is an example of what one piece of the data flow, which is every time a session is created, it's added to this flow timeline where you can see the user flow. You can see all the tags and locations that session was created on. And you can start tagging your data with the version of the backend server. It was using the client side permissions and flags that were set, the front end version, the location, the time of day, other feature flags. And you can really start to get a bigger picture about what's going on in terms of a data sample that you can use to target your analysis. At HeadSpin, what we believe in is a DevOps friendly environment where everything can be done via API, everything can be done via UI. And our goal is that every piece of your platform, whether it's your integration server or your alerting system, can be participating in this data flow and getting insights from the data as it's being generated. So this is an example of how you can make an API request to create a regression worker that continuously outputs results and is queryable by your infrastructure to understand how the user performance is. So what this is an example of comparing the previous build to the current build continuously, using various categories of labels within every session. So how long it took the page to load, how long it took the application to launch. So we're going to be looking at changes specifically in those factors. We set up a threshold, which is the number of data points per comparison bucket. You can think of this as a continuous flow model. When you're continually having new data flow, you might have your tests running and one or two sessions show up. And what this means 10 is we're going to wait for 10 samples from the latest build to show up before we compare it to the previous build. So the beauty of this system is that with a continuous data model, data is always coming up. And if you tweak the thresholds correctly, what you end up with is confidence that you're making the right comparisons between the bucket A and the bucket B. You give it a user flow name. This is the user flow to restrict the analysis in. So this user flow is a sample, but this could be, for example, testing my login, testing my payment checkout flow, testing my core subscription flow, or testing my core onboarding flow. So there's many different user journeys that testers are testing. In this case, you restrict the worker to one journey, and then the worker is created and it lives on our platform indefinitely. So it has an ID, it's able to be started and stopped via APIs, and it's able to output results that show you what is exactly changing between the current build and the previous build. And our vision is that these workers will be very ubiquitous throughout your entire practice. So in your CI/CD server, you'll be creating workers. In your live site monitoring, you can create workers. And then you can also create workers just ad hoc. So as part of your exploration of the data and trying to get more of the data. So for example, if you have a testing practice that's creating thousands of sessions a day, and you just want to start to understand how are things changing over time. So for example, how does one location compare to another location? It's very easy to go into the UI or the API and just create a worker that starts to continually analyze and output a trend of how different locations compare to each other. And our view is that by allowing you to repurpose the testing data, by asking these deeper analytical questions that help you make more decisions, we're helping your team be more efficient. We're helping your team reuse what you're currently doing for more purposes and move faster and ship faster. And we're really excited to show you what regression looks like, how to use it, and then take any questions at the end. So at this point, I think it'd be a great time to transition over to Ilya, who's the head of our sales engineering and customer success, and have him run through a demo of what regression intelligence looks like.
Thanks, Brian. Happy to do that. Let me just share my screen once yours drops off, and I'll take folks through it. And folks, if you have any questions, please type them into the chat. We'll be happy to answer any questions at the end of the webinar. So what you see on my screen here is a smattering of devices. And of course, HeadSpin is based on real devices in real locations all over the world in different regions. So you can look at how your app runs on different types of devices or different locations. Obviously, very important if you're going to, launch a new version in a different market, if you're going to enter a different market, if you want to look for things like, localization changes between, say French Canadian and English in the, Canada versus US, if you're going into some foreign market, if you are in a foreign market and you want to come to the States, whatever the case may be, we have real physical devices. And for this demo, we have a few different things to show you. Some I'm still working on and some from previous things. So in today's demo, let's start with something really simple, right? We have a Galaxy S10 in Boston and we have a Galaxy S9 in Boston. And each of these devices basically has the eBay app installed. Just a regular eBay app that I pulled down from the internet, tried a few different versions so I can show you an idea of what this might look like. There's not one installed here right now, so we can actually background this and run a quick installation process, which will, let me just show you. It will basically uninstall the app if it's there. It will install this particular version, the latest one that I've been looking at, and then it will run the Python script, which is basically going to give us a test case. So I ran this previously to build up what we call a user flow. So as you can see here, I have a bunch of different user flows for different apps that we use for demos and testing. And so here's my eBay user flow. Now remember, this is not any kind of internal eBay build or anything like that, right? This is just the eBay app taken from the Play Store, installed on the device, but I did get a few different versions of it. And so right off the bat, what you're seeing here is one of the things that we like to talk about when talking about comparisons, right? Remember, regression is really just a versus B compare operation, right? So the question is, what do you want to compare? Now, one very common comparison is look at different types of phones. So in this case, we have two phones, but they're in the exact same location on the same Wi-Fi in this case. And so we could really look at what does the same app look like when you test it on one phone versus another. So what you're seeing here are 3 runs of that test that I showed you previously. And I'm comparing this with the S9 compared to the S10. And the S10 is down here. And then I did some other versions so we can talk about a build over build regression down here. So one of the interesting things we have is essentially comparing, an S9 versus an S10. What does the eBay app look like when you run the exact same version of it on 2 different devices? And I have that over here and over here. So one of the cool things about this is you can do this as a side-by-side, right? So we have an eBay test on the S10. Actually, this is the, I see it. This is actually not the same. This is comparing 2 different builds across the same device, which is also very interesting. But what I wanted to do is more compare the S9 against the S10, which is over here. So what we've done is we've basically set up a regression worker that looks at the 2 tags that I've applied. In this case, I'm doing the phone type tag, right? So I have 4 sessions that were pulled on the S9, 3 sessions that were pulled on the S10. So one of the things that happens automatically is the system will actually use that AI regression workers that Brian talked about to essentially analyze all the sessions and come up with a 3-to-3 comparison. So it actually looks at these 4, it figures out which 3 are the closest to these 3, and then tries to do its best to give you an apples to apples. And in this case, you're basically looking at the issues that HeadSpin found. Now, one of the issues that we found is when you look at these 3 versus 3 sessions, there is actually an increase in the app launch time. And the increase, as you can see here, is 1.3 seconds. And it's essentially only affecting a third of the sessions in the B bucket, which is the S10. So essentially, the app launch was about the same on all of them, except this one outlier, which might be interesting to look at. And remember, we have the details for all the sessions. I will show you that in a moment. The other thing we look at is this is running an Appium test. So one of the things we can tell is whether Appium itself is actually working better or worse on one device versus the other. And it looks like a pretty inconsequential difference. It's a third of a second over the test case. Of course, it's like a 2-minute test case. So a third of a second is not really a big deal at all. Now, what's interesting is the low page content. And this is where stuff makes sense, because you would expect the S9 to be slower and have more issues than the S10 being a newer device, right? And that's what we're seeing here. So low page content is one of the automatic checks that HeadSpin does that identifies areas where there's just not much going on the screen. And, this little indicator here tells us that 100% of each of these sessions are affected. In other words, the S10 works significantly faster than the S9. And the S9 has more areas where there's just a gap while we're waiting for something to load. And again, we can actually drill into the details of this, which we'll do in a moment. The other thing is the S9 has more areas that are affected by higher battery drain. One of the things HeadSpin does is, of course, it detects, battery discharging or battery charging more specifically. And so we know when the app is running and causing the battery to discharge faster or slower. And that's essentially what's identified here. And this sort of lines up with the idea that, the S9 is a slower device. So if I go back here and let's just take a representative session up here, right? And then let's grab one of these down here and we can look at them together. And actually I can show you exactly what the test was doing, what the tags are, et cetera, right? So this is 68012. That's the build number on the S9. And basically we load the eBay app. The app starts. Takes a little while. As you can see, there's a kind of a pause screen while it loads, and then it comes up with the main screen. And then the test actually will do a search for, in this case, pizza ovens. And we're trying to keep things consistent, so we're always searching for the same thing, right? Now, one of the things that HeadSpin does, of course, is it then records areas of, high battery drain, low page content. So if you look at low page content, for example, it's essentially flagging this splash screen, which is no surprise, but that's quick, right? That's 500 milliseconds. And then it's flagging a 4.37 second impact over here while there's nothing happening, right? The app is just kind of frozen while it's thinking, and then it actually displays the rest of the data. Now, if you look at the corresponding session on the S10, here is the same build, 68012 on the S10, and we don't see that, right? We do see a low page content because this, the eBay splash screen is almost instantaneous. And then we basically have this blank screen here that we're looking at, and then the app loads, but it's much shorter, right? This is 3.16 seconds. So it's significantly shorter and faster than the S10. And then we have another interesting thing, which is the, we call this the page load API, or the page load capability, I guess, more correctly stated. And what it allows us to do is essentially select any area. Here, if I zoom in, you can see this a little bit better. This gray outer box is essentially an area that we select when Appium tells us that this screen is ready to go. So right when we click the enter button, if you will. And then, the search takes place. It takes some time. Then the search is ready, but we're waiting for the elements to load, right? The actual images. And then finally, the search is finished. And this is kind of where the end of this is. So in this outer gray box, we've actually requested one of our AI modules to identify frame by frame analysis of this gray box. Tells us this is the first time there's a frame change. So that's when the search begins. And then this is the last time that there's a frame change, which means the search has ended and essentially everything is now rendered and static and ready for a user to perceive that, hey, you know, this search is done. And this gives us a specific time, right? 1.47. And that also is something that we have access to in this regression API. So we have these labels. Labels can be anything. Your test can actually insert labels arbitrarily wherever you want to. We insert some labels around the different Appium commands that we're running, or, you know, we have this page load API. And the page load API is what I was just showing you. So we have a first load, which is kind of internal, built in by us. And then we have custom labels like the search time, which is the one I created. And as you can see from the search time, the average, or mean in this case, right? The mean regression is actually around, the total is 787 because it's taking into account the first load Appium and the search time. But the search time is actually slower on the A phone, which, if you recall, is the S9, compared to the sessions on the S10. And again, this says it's affecting 100% of the sessions. So that's how I know that this has taken into aggregate all the data available and then has given me the mean. So in fact, the mean overall is that the first load Appium is actually worse on the S10, which is kind of an Appium artifact on that device. But the actual thing I care about, which is the search time, right? That's actually faster, about a quarter of a second faster, again, going by the mean, on the S10 versus the S9, which is kind of what I would expect, right? So the mean duration for doing an eBay search on the S9 is 1685 milliseconds versus 1450. And so this is something that I can use to make decisions. You know, is this a big enough difference that I need to go and re-architect my app, or is this fine? Now I'm just doing this on two phones, right? An S9 versus an S10. So you could really expand this out. You can do this on a bunch of devices, or you can start doing this on locations, right? So here I have 3 sessions all in one location on an S9, but I could just as easily run it in, you know, the Midwest, the East Coast, and the West Coast on an S9 and S10 and do it that way. And so this regression API really allows you to define for yourselves, what is it that I care about? Am I interested in identifying issues because of a certain geographical location, because maybe your servers are centralized and, you know, you want to understand how the user perceived metrics would be affected by distance? Or do you care about a build over build regression, right? And if we wanted to do a build over build regression, just coming back to here, you know, one of the things we can do is like take, you know, build, let's see, I wanted a 68012, and this will tell us, you know, how many sessions are affected or how many sessions are tagged with that build number versus build, let's say 611. Oh, yes, it helps if you write the correct character down. 611, we have 61109. And so I have 2 sessions tagged with this build tag, and I have 2 sessions tagged with this build tag, right? And this is what Brian was talking about, where a different application of this is if you have your pipeline set up so that every time there's a new build, it gets installed on however many devices you want. The same test runs on it, perhaps multiple times, just to get kind of a nice median going, right? And then you can do this regression compare. And again, I'm doing this in the UI just to show you the, you know, the capabilities. But of course, in a real pipeline, this would essentially be done automatically after every build. And we'll talk about the, you know, the alert watchers, which is what allows us to do that. So in this case, if we view the regression of these 2 builds, now we're essentially saying A is build 68012, B is build 61, you know, 1019. And so now we're looking at kind of similar idea, right? But now we're identifying differences in the build over build, in this case, running on the same devices, which in this case is running on the S10. And so again, we have some differences around battery energy drain, except now, of course, this is not because of 2 different phones. This is actually the same phone running multiple copies of the same build, or different build, I'm sorry, right? The 68 versus 611. And so version 6.8 versus 6.11 is what we're looking at. And this is, you know, this is what we can see here. We also have, you know, the labels over here, which once again, if we go back to the search time, we see that here on the exact same device, build over build, there actually is a bit of a regression in the search capabilities. And remember, this is all taken with, you know, these 2 different builds on running on the same device, on the same Wi-Fi. So, you know, you essentially can choose which things you want to keep constant and which things you want to vary. And that is what this enables you to do. Now, again, if you put this in a pipeline, it's easy because everything is on the same trend graph. Everything happens in that pipeline. So once you define what it is you want to kind of have a record of, and so how you want to do the regressions, once you put it in the pipeline, then it just remains fixed. And every time there's a new build or a new set of tests, or a new device or new location, whatever it is that you're choosing to compare, you can essentially, look at it that way and then get to the actual data that matters to you, in this case, search time. And so, what I can see is I have this regression. It's a pretty small regression. So, maybe there's no issue there. And again, if I want the raw data, I can go back and look at the raw individual data on, that we can get from these sessions. So that's the, capability of the regression API. The other thing we have, of course, is, the performance monitoring, which basically just graphs everything. So this is where, in this case, the performance trend graph is a little misleading because I have these two devices. But if I just choose to focus on the 970, then essentially I'm comparing different builds, and, something is causing a spike up here versus here. So again, I can basically, if these were properly tagged with build numbers, I can regression compare them, or I can just compare them from the UI by clicking on here and going to that session. Again, just, we mentioned this briefly, but I had this up on the previous screen, but find representative sessions. This will actually try to line them up on the same timeline, so you can, kind of put them into the same reference point and then go from there. This takes a few seconds to crunch the data, and we can decide, what representative sessions do we want, or we can choose an actual, confidence interval here. So if I ask it to find me some representative sessions, right, it will do that, and then we can look at kind of a side-by-side of putting them up against each other, as I've done previously. So let's say I want the P90 here. If I want the 90th confidence interval, basically we have these two sessions, and remember, these are the two different builds, right? These are the tags here, and these were done on the same exact device as I mentioned, but they're two different builds. And so what we can do essentially is, we can line them up so that they are in the same place. Let's say I'm focused on the search, right? So I'll move this to where the left device is starting its search. And I can take this down here and I can actually move it. So I'll actually line this up with the right device being on the search for anything screen. And then I'll move the left device to kind of line up to that same, oops, sorry. It's a little bit hard on this screen, but it's a little easier for you guys to see it if it's not a large enough magnification. So let's see, I want this guy over here, right around where the search for anything screen loads. Yes, and now that they're aligned based on this, what I can essentially do is start from here, and now we can actually see the kind of side by side. So notice on the right-hand side, there is that tiny little refresh just for an instant. It's actually there on the left-hand side as well. These are basically very closely aligned. I'm talking, maybe a delta of a few hundred milliseconds. Yeah, and then we can essentially see kind of what one is doing versus what the other is doing. And we could literally watch these images load and how it's a little bit slower on the left one, right? So you can kind of, visually realign it if you must, and then basically look at these on the same timeline. And look at the, the yellow bar, of course, shows us the various issues that we're finding on, the representative session on one versus the other. And these are the links to the actual session. So again, if I want to see, this one versus this one, for example, we can go to it from there, and we can actually look at these two sessions, and we can see, exactly what's happening in, one versus the other. So this is 6812. This is 6.11, as I mentioned earlier. Here's the search. And, this basically shows us everything. Now, while I'm on this page, for those of you who are not familiar with the other capabilities of the tool, on this screen, we're basically, recording everything that happened in the screen on this session. We're recording the Appium and device logs, which you can download from here, right? So I can download the MP4 device Appium log. And then on the left-hand side, we have the various types of issues that we're finding. So for example, low page content, which, in this case, the splash screen is really slow for whatever reason, right? And then there's a much shorter loading time over here. So that's the left-hand side. And then here in the middle section, we're basically identifying a lot of data from these devices, right? So we have various video metrics. We have the CPU and memory metrics here as well. So one of the things we can see is like this splash screen, for example, it's static, right? There's really not much happening on the CPU. Now the frequency is increasing, sure, but the net CPU usage remains pretty low and pretty constant until the app is actually up and running. So it kind of implies that this is a static splash screen, whereas this over here is actually processing and doing stuff with the data, right? So that's kind of an interesting design decision to have a static splash screen, if that is in fact the case. These are your I/O reads and writes that may shed light on, how it's loading data or writing data. This is, by the way, this is a first install of this app. So, it could be writing a bunch of stuff to cache here as well. And then, of course, the battery energy drain. And as you can see, we're showing the instantaneous battery current, as well as the, cumulative battery energy drain as a total percentage, right? So, this again kind of tells me that this thing is just sitting here for some reason, right? Even the battery is not really doing much. So again, kind of identifies a static splash screen. Now, in some cases, we're capable of recording network traffic that passes through the device. In this case, since I downloaded this from the App Store, that is not ready to capture the network traffic. So we don't have the network side of the equation to analyze. But if we did, then of course we could also look at that in the regression as well. So in conclusion, we can talk more about HeadSpin. And if anybody has any additional questions, as I mentioned, please put them in the chat. But what the system allows us to do is essentially create either manual or automated test cases. If they're automated, they can go into a pipeline. And if they're in a pipeline, then you can essentially run your regression workers in the background, which HeadSpin will do for you. And ultimately, it will either allow you to do this manually from the UI or make it part of your pipeline. As Brian showed, you can essentially create these workers and they will run in the background and identify issues and then ping you if there is a serious enough, regression that's worthy of a developer's attention. So that's it. That's all I have on the regression side. Now, again, if you have any questions or anything else that we can show you, please mention it in the chat, and we're happy to answer those questions.
Yeah, great. Thanks, Ilya and Brian. This kind of goes along with what you were just talking about, Ilya. Someone is asking, you mentioned some KPIs like image loading. Can you check performance of audio and video? And I think you did mention video at the very end there. And I know that's probably more of our platform product, if you wanted to touch on that for just a minute.
Oh, sorry, I'm on mute. Yes, that is an excellent question. Let me actually reshare this and pull up a video test. So hopefully this YouTube test cooperates. I haven't previewed this in a while, but basically, yes. So HeadSpin has audio and video capabilities. In fact, now on the video side, as you've already seen, we basically capture a full, video of everything that's happening on the device. And as you can see here, this is all the setup to get the app up and running, find the right content. And then once the content goes into full screen, we're basically capturing what we call the video quality MOS, or mean opinion score. This is our own AI algorithm that basically rates the average user perceived quality of the video. And then we have the actual data coming from direct measurements, right? So blurriness, blockiness, contrast, brightness, colorfulness, page content, in some cases frame rate, and then of course screen change. So when you look at this, basically you can see we're measuring like the blurriness of the video or the blockiness. So here it's pretty good. Here there's a bit of a spike because the background is moving very quickly. In the actual native video, of course, maybe a little bit hard to see it on a frame by frame basis. Colorfulness, etc. So yeah, we have a full suite actually for measuring video content. And as I mentioned earlier, with network capabilities, we do have the ability to pick up network traffic as well if the app allows it, essentially. So for example, in this case, like we could actually see the, the full, the full request over here. It's a post request. Here's some data about it, right? We have the response coming back, all the timing, the time spent waiting for the response to come back from the server, the response actual download time, etc. So that's the network side for those who are interested. But yeah, for video, we have these capabilities around looking at the video quality. For audio, we can actually capture the audio as well. And there's a couple of ways we do that. We don't have a generic rating of the audio, but what we can do is essentially record an audio sample that you provide and then record the video and audio on a device, right? Could be a, an Amazon Fire Stick. It could be a Roku. It could be an Android phone, like in this case, or an iOS device, Apple TV, set-top boxes, whatever kind of media device you have, we could record the video and the audio. And in the case of audio, we can actually compare it against a golden record, right? So if you have, a sample of audio, we can essentially compare what we recorded against that original sample. It's great for video and audio application. It's also really great for testing voice conversations. So, video teleconferencing, or even just phone calls, right? We do have real devices with SIM cards. So we can, and we have done a lot of telecom testing where you simply, place a phone call and play back a message that goes into one phone, is received by the other phone or device, and then record it. And then we can compare it with what you put in there. So this is something that we routinely do. Excellent question. Thank you for asking.
Great. There was another one, which I think you did touch on, but it says, are you testing on real devices, or is this a very good simulator?
No, we test on real, actual physical devices. So each of the devices that that I had on my screen, the S9 and 10 that we were using in the eBay example, all these devices that are available here, these are all real, actual physical devices. And as I mentioned, AV devices like Apple TV or Fire Stick, Android devices, desktop browsers, we also run on real hardware. So these are not, virtual images. These are actual real desktop machines that are running the browsers. These are real iPhones. So yes, this is all real stuff. And honestly, I mean, if you're talking about, measuring performance or measuring, what an S9 looks like against an S10 on your particular app, you have to do that on real devices. Otherwise, there's no point talking about performance. And so, yes, all of these are real physical devices that we have placed in data centers in various countries around the world, and we make them accessible to our users for all kinds of different testing.
Great. And this question I think came in earlier when you were focused more on regression intelligence. Can you map or plot out trend lines of how the app is performing? Like, do you have that ability?
Yes, absolutely. We have a few different ways of doing that. In fact, one thing we have, of course, is what I was showing, which is just our we call it the performance monitoring tab. And that's meant to be like a quick and dirty way of looking at this data across a few data points. So that's, one capability. The other thing, of course, is the whole point of the regression workers is you can basically have them run after every build or every event, every, test suite run that you do, or you can have them running nightly, right? You can have them running every hour or every 24 hours, whatever you want. And that would give you the raw data, which you can then, of course, plot into any kind of visualization that you might have by, on your own. And then the third thing, which I'll bring up in a moment, is all of these data points that we're collecting, they're all in a dashboard. They're all in a database, right? And we can actually give access to that database to each of the customers. So essentially, you have data, you have access to the raw data that makes up all of these data points. And so as an example, let me show you this dashboard here. So because you have access to the raw data, you can actually export it and essentially operate on it however you like. So if you have Tableau, or if you have, in this case, Grafana, if you want to visualize the data, you can do that. And a few different ways of doing that, right? One is, as was mentioned, a trend graph, right? So, here's all my testing running over time. In this demo example, like imagine this is a WeWork app, right? So we're testing it across different devices in US, India, UK, and Japan. If that were the case, then, here's a trend graph of kind of how the app is working. And again, it's up to you if this is build over build or just, the same app running, tests over and over again on the production version. It's up to you. The other way to visualize the data is something like this, right? Where you can take the last X number of test runs, aggregate them, and then plot them on this kind of, user journey. So if you imagine what does the WeWork app do, right? A typical example that we came up with for, the WeWork app would be, you log into the app and you basically navigate to a certain building, find a desk, book the desk, maybe cancel your booking and log out. And by plotting the data this way, it makes it very actionable because I can see that, in Japan, launching the desk is very quick, but in the US, it's actually very slow. And then on the other hand, the login is clearly the longest step in the overall user journey, but it's actually much faster in the US compared to Japan. So that gives me something that I can look at. And of course, down here, we have links to the actual session data. So we can actually look at each individual data point and say, okay, you know, why is there a spike over here, right? Why are these desk search operations so slow? And then of course, we can pull up the details and look into it. So you can plot the data over, you know, on a trend graph over time. You can come up with this kind of visualization. Ultimately, the data is available for our customers. So if you want to, you know, kind of pick out the KPIs that matter and, you know, plot it on any kind of graph, you can do that.
Great, perfect. Yeah, another question came in. It's kind of interesting. How's battery measured if all devices are plugged in? It says to the light, but I think just plugged in.
Yeah, no, that's a
can,
great point. I think the important thing to realize is anybody who's ever tried to create a device lab, you very quickly learn about batteries, you know, bloating and exploding because they're constantly being charged. And that was one of the first things that we solved at HeadSpin is, you know, we actually have smart charging hubs for all of our devices. So in all these data centers, these devices are essentially, they're not always plugged in. They're actually plugged and unplugged as needed. Now for the actual battery testing, there's a few different ways we do it. Like so at a high level, we're basically measuring the current that's going into the device. And that allows us to track the true, you know, charge that the battery is consuming. And so we can correlate that. And that's one of the best ways we have, because again, we have our own ASIC, we have our own hardware that allows us access to this, you know, physical information, in this case, physically from the charging circuit, which we control. And so the, you know, the short answer for the battery is we know how much current is going in. The longer version is, you know, we have other controls, but essentially we control the charging circuits. And that's also great for improving the life of the device and being able to control it.
I'd like to add a few more points on that, and great answer, Elliot. With battery testing, there's a lot of factors that go into battery. So for example, the CPU might be one of the factors. Obviously the screen draw is another factor. Some of the hidden factors that we see are actually the network. So when you go into cell scans, Wi-Fi scans, Bluetooth scans, these are battery events. Also, when you go into I/O, so when you first open an application, it does a lot of disk I/O, and that's also what we see as typically a large battery draw. So from our perspective, where we sit and we look at the whole energy usage of the device going into the device, we actually are able to capture a lot of these edge cases that otherwise would be sort of hard to catch, which is we're able to see sort of total device energy usage. And so from that framework, it's pretty eye-opening, right? Because you can see how everything comes together into an energy and heat profile with our platform. And that's something that developers really use to understand how to optimize different parts of the application.
Great. Another question came in. It says, have you thought about installing devices in Latin America, not just Brazil?
Yes, the pool I was showing is just a small selection that we use for demos. It's just one particular, you know, set of devices that we have for demos. We actually have 70 different countries, installations all over the world, including more in Latin America. You know, if somebody has a specific country that you're interested in, let us know. We have a few. We're actually working with customers in Latin America outside of Brazil as well as in Brazil. So that is a, you know, a market segment for us. So if you have a specific set of countries or set of locations, you know, please reach out and we'll be happy to work with you on it.
I saw Colombia pop up, and we do have presence in Colombia through our enterprise plan, and that's something that you know, would love for you to get in touch with us to talk about. I also want to mention, as part of our vision of a DevOps platform, we think that there are opportunities where HeadSpin is great at hosting and giving access. So for example, there are locations in the world where you could not get access on your own. and HeadSpin as a partner will help you get access to those locations. There are also locations where you might already have access. So we frequently hear from our customers that they have customers in certain locations they want to test. They have users, they have developers, maybe with a distributed team. And our view at HeadSpin is that we want to build a platform that enables your team to be most effective and efficient with what the resources you have. So in some cases, we can host the devices, and that works really well where we have presence. But we're also looking forward to how can your distributed team, how can your customers also be part of your DevOps platform. And so for your customers, we have this ability to do what we call on-premise. You can put boxes at customer sites. These boxes are enterprise grade. They can run within the customer site and collect data of the real user experience in that region, even on corporate networks that might be hard to get access to. And we have a new direction we're moving, which is called bring your own device. So anyone with a device, it could be your distributed team, it could be your customers, it could be contractors you hire, can actually just plug in a device to a computer, and then that device shows up on the platform, and you can do everything with it that we just showed. So this works for the Android. There's an update coming for iOS very soon, and you're able to basically take any device in the world that you might have access to and connect it to the platform and use it with regression intelligence. So we're super excited about this as a direction, and our team led by Ilya can demo and set up custom packages that help you get what you're looking for in terms of device coverage and device infrastructure to help you achieve your testing and development goals.
Great. I haven't seen any more questions, so I thank you both of our awesome speakers today. And thank you for everyone who has joined us. And you will get a recording sent to you probably by tomorrow, and appreciate your time. And please feel free to reach out to anyone, Ilya, Brian. We can all help you answer any additional questions you may have.